Hello, welcome. In this short video, let us look at the derivation of the expressions for the summation of geometric series. The classical geometric series defined as summation n equal to 0 to infinity x power n is equal to 1 by 1 minus x for x less than 1. So let us call this expression or this sum equal to L. The summation, let us label this as L. Then the capital L is equal to, we can write the series as 1 plus x square plus x cube and so on. And since x is less than 1, this summation is definitely finite value. Definitely equals a finite value. So we can define another summation multiplied by x, that is x times L is equal to x plus x square plus x cube and so on up to infinity, up to infinite terms. Note that these two summations are actually finite values. Then we can define the difference between these two values, that is L minus XL is equal to, we can clearly see that all the terms except the term 1 cancel out. So we have this difference equal to 1. Therefore, the summation, that is L denoted by the letter L, is equal to 1 by 1 minus x. Hence, the summation for the classical geometric series for x less than 1, summation n equal to 0 to infinity x power n is equal to 1 by 1 minus x. Thus, the sum of the infinite series with the value x less than 1 is equal to a finite value given by 1 minus x. Here let us look at the derivation of the expression for the summation of an infinite geometric series defined as summation n equal to 0 to infinity 1 by x power n is equal to x by x minus 1 given x is greater than 1. So we want to prove that for a value, that a positive value greater than 1, the infinite sum, that is defined from n equal to 0 to infinity, is equal to a finite value defined as the ratio of x and x minus 1. So let us look at the summation or the series of the series in this. So let us define 1 by x as equal to y, where y is less than 1. Since x is greater than 1, y is always going to be less than 1. Then this series becomes summation n equal to 0 to infinity y power n, which is going to be equal to 1 by 1 minus y, where we use the summation of this series n equal to 0 to infinity y power n is equal to 1 by 1 minus y for y less than 1. So now we have an expression for this summation. So by now substituting the definition of y, we have summation n equal to 0 to infinity 1 by x power n is equal to 1 by 1 minus 1 by x, which is equal to x by x minus 1. So note that this can also be written as summation n equal to 0 to infinity x power minus n is equal to x by x minus 1. And this is only true for x greater than 1. Thanks for watching.